Hi everyone, so in this video we're going to talk about the history of the atom and kind of walk through some major scientists and some timelines. So the first scientist we want to talk about is James Dalton. Now, James Dalton is not really tested, but it's important to note that he thought the atom was a sphere and it was solid and the smallest particle. Okay, he thought that you could get no smaller than this atom. And so his model was called the billiard ball model, and that's because it kind of looks like a billiard ball, or if you've ever played 8 ball on your phone or played a game of pool, the little balls that are on the table. That's what he thought they looked like. And then about a couple hundred years after him, you had a guy named J.J. Thompson come into play. And what he discovered through his experiment using a cathode ray tube was he discovered that even though the atom was solid, he found out that there were these negative electrons kind of sprinkled in throughout. And so he thought the model still solid, but it had electrons kind of in it, and the rest of the atom was just positively charged and just kind of spread out throughout. Now, his model is called the plum pudding model because that was a thing in England and Europe, but for us, it's kind of easier to think about a cookie, specifically a chocolate chip cookie, where the cookie part is positive and then the chocolate chips are the electrons that are sprinkled in randomly all throughout the model. And so some good things about his model is that it has electrons in it, and so it proved to James Dalton that actually the atom is not the smallest particle. There are things inside atoms that are even smaller. But some cons or some limitations is that it's missing a lot of those smaller particles. His experiment only discovered the electrons. And so after J.J. Thompson came this guy named Ernest Rutherford. And Ernest Rutherford did this experiment using gold foil. And the reason why he was doing this was he had discovered these alpha particles or these tiny particles. And so what he did was he had a piece of gold foil like this, and he had little detectors or sensors around it. And he shot these little alpha particles at the gold foil, and what he expected was for them to hit the gold foil and to bounce right back because J.J. Thompson and James Dalton all said that the atom was solid. But what actually happened is instead the alpha particles went straight the through the foil. And occasionally they would have one that would kind of bounce and deflect. And so what he discovered is he knew that there was these electrons in the atom. And so what he realized was that the atom was mostly empty space, and that was why it was allowed to just go straight through the foil rather than bouncing back. And he discovered that there was a dense positive charge in the center. And he called that dense positive charge that was in the center, he called that the nucleus. And that was a pretty big deal. And so because he discovered the nucleus kind of on accident, it's called the nuclear model. And so it kind of looks like this, where you have that center positive part in there. And then he said that the electrons were in an electron cloud, just kind of around it randomly. So the electrons are in the electron cloud, which that might be a familiar phrase to you from middle school physical science. So yeah, mostly empty space, dense positive charge in the center called the nucleus. The electrons are in the electron cloud, and he called those all the individual charges. He started calling them protons, or another scientist did. To be honest, I haven't looked up, but we're going to credit it to Rutherford. And now what we look at is the next scientist. The scientist who came along was Niels Bohr. And he was not that far after Ernest Rutherford. Like, they were all both alive at the same time and doing a lot of cool things. And so Niels Bohr did an experiment, and what he discovered was that not only was the atom having the protons at the center, just like Rutherford said, but he said that actually the electrons orbit around the nucleus like planets orbit around the sun. And so we call his model the planetary model. And so with his, some pros to his is that these electrons orbit around the nucleus, and that gives us a pattern. Rutherford, J.J. Thompson, they all had the idea that the electrons are just kind of random. And he said that you could 100% of the time find an electron in that orbit. He said that's kind of where they always stay. And so he also, he still got protons in the nucleus. That stayed the same. The main difference is the new pattern with the electrons. And so what we see happen is electrons don't always behave. I like to think of electrons as being similar to teenagers. If you say you always have to be in this one spot, the first thing they're going to want to do is not be in that spot. And so this guy named Erwin Schrodinger and another scientist, whose name I'm currently forgetting, came around and they did some really complicated math. And they discovered that actually electrons can't always be found in those orbits. In fact, they said that there were regions of space, and they called these regions of space orbitals. So similar to orbit, but orbitals. And in these regions of space, electrons could be found 90% of the time. So he said this is just kind of like where they are. And so with Schrodinger's model, you still have protons in the center, and then these orbitals of space, or orbitals, these regions of space, kind of make these little shapes. So one of them looks almost like a figure eight around it, and the reason why I'm drawing dots is because it could literally be found anywhere in that region. It doesn't follow a particular path. And so he said some were shaped like a circle, some kind of doing this purple in a circle shape around it, so a sphere. Some of them had that dumbbell shape, but mostly he said electrons could not be found in the nucleus, like really, really close to the nucleus, but it would be spread apart, and there were energy levels and things like that. And when we learn about electron configuration and the patterns that electrons make in these orbitals, it'll start to make a little sense. But he said that there were these regions of space called orbitals, and electrons were found there 90% of the time. And so one of the things, though, that's still missing are the neutrons. And so after Schrodinger had kind of developed this model for the electrons, a guy named James Chadwick came around and discovered the neutrons, because he said, hey, the atoms are still weighing more than what we thought. And so essentially what he did, Chadwick, he took Schrodinger's model and he just modified it slightly. He said, okay, in the center of the nucleus, there's actually protons and neutrons. And so these neutrons had a neutral charge, and the purpose is we know that like charges repel. So if I put a positive next to a positive, they're going to bounce apart and repel. And so the neutrons provide a buffer between the positive protons. And so we still have the pattern of these orbitals, which some people don't do the dots, they kind of just draw it like this, and then the spheres, and then they keep getting bigger and bigger and bigger, and it gets a little crazy when you're drawing them. And so what I want everyone to understand is that the orbitals are current. Like, this is what scientists currently believe, although things are changing. Protons are made of quarks and all kinds of crazy stuff that you can look up that's new. But for the most part, this all holds true at the high school level. Orbitals are current. However, we usually draw the Bohr model in class. And so the reason why we draw the Bohr model is because it's a lot easier to understand and it's a lot easier to draw. These orbitals are really best if you see them in 3D, which requires computer simulations. And so most of the time you're going to see the Bohr model in class, but know that they do not just ring around nicely around. They kind of hop in and out of these orbitals, because keep in mind, electrons are like teenagers. They don't like to be told what to do. If you have ever touched something and been shocked, that is an electron jumping from whatever object you touched to your hand. And so electrons move around. They don't even always stay with the exact same atom that they were before. So you can't guarantee that they're just going to ring around the nucleus the way you might think. And so that is kind of the idea of what's going on with the history of the atom at a basic level. On a test, you would need to be able to compare and contrast these models, what makes them similar, what makes them different, but you'll also need to talk about the merits and limitations of each ones. And so this is kind of a fancy academic way of saying your pros and your cons. Okay, what's good about it that it discovered that wasn't there before in the model of the atom, but also what's still missing or what's still wrong or incorrect about the model. So hopefully this video helps you study, and I'll see you in the next video.